tutorial explains how to set up a compound table. So we first integrate the TIC and we identify all the peaks. This is done like indicated before in the video tutorial, qualitative identification. So here is the identification, and in our qualitative table we have the spectra and we see here the correct identification. So producing a compound table based on this spectra means we want to quantify a selected ion. Say for example for dichlorophosph the dominant fragment is 109. So making a calibration curve, we would quantify mass 109 only. The reason for it is because the 109 fragment has a much better signal to noise than the TIC. So we see that even in this strong TIC signal, which is much more dominant in the smaller peak area, that's the reason why everybody who's making GCMS analysis quantifies only one ion or a class of ion, but not TIC. The signal to noise ratio is much better. So when these peaks are all correctly identified, which I assume now, I click Create Compound Table. And this jumps into a sub-menu, and the first icons here, peak integration for all TICs and qualitative table and manual similarity search, are icons which we faced already in qualitative analysis. This was only programmed to have that in if we want to correct something. That's not necessary now. Usually in qualitative analysis we have already checked all the peaks. Also, the layout of the software changed. When we had qualitative analysis, we have a chromatogram and maybe mass chromatograms and spectra. If we click Create Compound Table, the software changes the layout and the non-filled compound table appears on the bottom right. We still have the spectrum and we have the quantifier peaks window here, which will be filled when there is a compound table. Also, calibration curves will be filled in here. Actually, the layout is just switching windows because the software has all these windows in the background. Like I can show now, I can manually set up this layout. This is just automatically switching between qualitative and creating a compound table layout. So we start on setting a new compound table. So we have two wizards here. The wizard new creates a new table. The wizard modify modifies the table if there is changed retention times or a retention index has to be set afterwards or something like that. Wizard new means we create a compound table and the software automatically selects the spectrum process table. All spectra of the peaks are stored in the spectrum process table, and the software knows the fragments from the spectrum. So to create a compound table and the corresponding target masses, it uses by default the spectrum process table. The next step just displays that we had 14 spectra in this table, and the next window, which is the third of 7, shows all these spectra which are all compounds. So we can even take out one or two of those if we want in this step, but we assume that we have checked this already in detail in qualitative analysis. In the next step, compound table wizard number 4, page number 4, we have already quantification methods to be defined. But actually this can be defined later because we are processing inside the data file. We are creating a compound table inside the data file. And later on we save that as an individual method and we define these parameters then when we create a calibration curve. So we can ignore this window at the moment. The next step is we focus here on the right side. The left side, again, we leave concentrations for later on, but ion settings we can define MC, which is called mass chromatogram. The software automatically assumes quantification is based on mass chromatograms on quantifier ions only. TIC is the worst case, and some people like to have groups of compounds between some ranges of masses between two different masses. That's MIC, multi-ion chromatogram. The default for reference ions is 2. That's a normal in GCMS analysis. And the decimal for mass should not be none. If that is none, all ions, all masses are rounded up to integers. Say, for example, if we have 272.4, this is rounded down to 2.272. So I recommend to take one decimal here. Default ion allowance, this is the allowance, the range of intensities of qualifier ions to quantifier ion ratios. 30% is a good value to start with. The next window shows already very nicely each ID. It gives by default the name which was identified in the qualitative identification. By default it takes automatically the most dominant fragment, the most intense fragment here as quantifier ion, which is called target ion in this software, and the two second most intense peaks to be reference ions. So it checks later on in unknown analysis whether the reference ion with 1845 has around about 24% plus minus 30% in variation relative to the main target ion. Manually we can change, if there is coelution of that mass, we can that set to be not used. Instead we can select manually that as a reference ion. So this is possible, but automatically the software does this for all the peaks. So it's very easy to produce a compound table by just pushing next and finish. And that is very nice. We have here now our compounds. The dichlorophosph here is this peak in the TIC, but now the corresponding masses we want to quantify are shown here. It's the quantifier ion 109 automatically and the two reference ions we discussed. So this compound table contains the quantifier ion retention time. There is no retention index defined here. We have reference ions. If we click in this box, we see the reference ions in the corresponding ratio. Default means that is the 30% allowance, but we can change that individually, and we can also change the selected reference ions even here in that window. Concentration we discuss later, and event indicates that these peaks quantify in scan. Event 2 is ZIM. This standard spectrum is registered. This is an important thing because we can identify quantifier ions by or compounds by reference ions, but in this software it's also possible to compare it with stored spectra, and these spectra registered here are the spectra acquired with the instrument and which were stored in the spectrum process table. So if I go in here, right mouse button, and display standard spectrum, then the standard spectrum stored in this compound table, which comes from the spectrum process table, is this standard spectrum. And of course it's very close to the one we see on the top measured, because this chromatogram has very neat peaks and there is no difference. But when there is a lot of matrix, this measured spectrum might be different, but it's helpful to see the standard spectrum as well. If we store that data file here, the compound table is stored in it, and if we want to extract it for a method, because we want to make a calibration curve later, we save the method as, and we give a name for that method. It comes with the original name where the data file was recorded with. So I define that calib, I save, and the software asks me current setting or required settings. If I would select acquired settings, of course all my changes has been lost, because the software stores the original method, which is the method with acquired settings, all the time. It can never be overwritten. But the current settings are obviously quantitative parameters, qualitative, fragment table, and of course data acquisition parameters, but also these compound table settings. So if I store that, this compound table is stored with all other method parameters in that method.